A 0 to 5 kHz voice band microphone is modeled as having a low pass first order frequency response with a pole at 10 kHz. If the microphone is sampled at 100 kHz, how much attenuation is required in anti-aliasing filter for 80 dB noise rejection around 100 kHz? We know that the magnitude function or the transfer function of a low pass filter is 1 by 1 plus j f by fc. So f is equals to 100 kilohertz, fc is equals to 10 kilohertz. So at this particular 100 kilohertz frequency, the magnitude of HLP of f is equals to 1 by 1 plus j10. Okay, in dB it leads to minus 20 dB. So we need to have 80 dB around 100 kilohertz. So remaining 60 dB attenuation from the anti-aliasing filter. Hence option B is correct. Electric field in reverse biased silicon PN junction is equals to 3 into 10 power 5 volts per centimeter. The doping concentration is 4 into 10 power 11 centimeter power minus 3. The magnitude of the reverse bias voltage is. Here built-in potential is nothing but Vt natural logarithm of Na Nd divided by Ni square which is equals to 0.826 volts. Here Nd is 10 power 17 and Na is equals to 4 into 10 power 16 centimeter power 3. Okay, there are Nd as well as Na both are given. Now for these values Na Nd by Ni square is 0.826. Now maximum electric field, so Vbi plus Vr is nothing but epsilon E max square divided by 2q 1 by Nj plus 1 by Nd. So which is equals to 8.008 volts. So Vr is nothing but 8.008 minus 0.826 which is equals to 7.18 volt. That is option C is correct. In the following circuit, the 30 volt source has been applied for a long time. The switch is opened at t equals to 1 millisecond. At 4 milliseconds, the voltage across the capacitor is. Here Vc of 0 minus is equals to Vc of 0 plus is nothing but equals to 25 volts. Okay, now at t equals to 0 plus 30 u of minus t is equals to 0. Now Vc of 1 millisecond is nothing but 25 e power minus t by tau. Okay, tau is equals to a parallel combination of R equivalent into C. So 5 into 1 by 5 plus 1 into 0.6 10 power minus 6 into 10 power 3. So 5 by 6 into 0.6 into 10 power minus 3 which is 0.5 milliseconds. That is 25 e power minus 1 by 0.5, that is 25 e power minus 2 which is equals to now Vc is 3.383 e power minus t by tau. Now Vc of 3 milliseconds is 3.383 e power minus 3 divided by 25 into 10 power 3 into 0.6 into 10 power minus 6. So which is nothing but 3.383 into e power is 3 into 10 power minus 3 divided by 15 into 10 power minus 3. So if we solve this one, we will get Vc is 2.77 ohms. That is option D is correct. Effective resistance between the base and the ground for the above circuit is, here input resistance means between the base and the ground is nothing but this one, Ri. Ri is nothing but R pi 1 plus beta into Re. Here R pi is nothing but beta by Gm, whereas Gm is nothing but Ic by Vt. Here Vt is nothing but 26 millivolts. We have to find out Ic. We know that Ic is nothing but beta into Ib. So this is nothing but 100 Ib. So Ib is given as 10 minus 0.7 divided by 250k plus 101k, which is equals to 26.5 microamps. So Ic is nothing but 2.65 milliamps. So we will get R pi as 943 ohms. So Ri is nothing but 943 ohms plus 101 into 1k. So it is approximately equals to 102 kilo ohms. That is option B is correct. Differential amplifier, the transistors are bias rate ICQ equals to 100 microamps and each transistor has beta equals to 2000. The amplifier is to be designed for common mode gain of 0.05 and common mode rejection ratio of 74 dB. Find out the value of RC. Here CMRR is equals to ED by AC. Here CMRR is 74 dB, which is nothing but normal, it is 5000. So AD is nothing but 5000 into 0.05, which is equals to 250. So AD is nothing but GMRC for the differential amplifier. GM is nothing but IC by VT, which is 100 into 10 power minus 6. This is 25 into 10 power minus 3, which is 4 millisiemens. So AD is equals to 250 divided by 4K is equals to RC, which is nothing but 62.5 kilo ohms. Hence option C is correct. Loop gain of the op amp is 92 dB. The gain error of the amplifier is, here the amplifier given is okay. Here the gain error is defined as ideal closed loop gain minus actual closed loop gain divided by ideal closed loop gain. That is, ideal closed loop gain is 1 minus beta and the actual is AOL 1 plus AOL beta divided by 1 by beta. So if we take 1 by beta as a common, we will get this as 1 minus AOL beta divided by 1 plus AOL beta, which is 1 by 1 plus AOL into beta, which is into 100. If we will get this as 0.0275%. That is option B is correct. Form